Hello students and welcome to the next module on numericals on simple harmonic progressive waves. Let us have a look at the numerical students. A transverse wave of amplitude 0.01 meter and frequency 500 Hz is traveling along a stretched elastic string with a speed of 200 meters per second. Find the displacement of a particle at a distance of 0.7 meters from the origin after 0.01 second. Students, too much data compressed in a few amount of lines. So first of all, we'll have to write the given data. First, we have the amplitude, that is nothing but A is equal to 0.01 meters. Further, we have the frequency given as 500 Hertz. So N becomes 500 Hertz. Further, we have the velocity, students, that is nothing but 200 meters per second. Later on, students, we have been given the displacement of the particle as X is equal to 0.7 meters. Why X? We have X because that particular displacement is the distance of the particle from the origin. Further, students, we have been also given the time, which is small t, as 0.01 seconds. Now students, we are supposed to find the displacement, which is nothing but y, and the formula, students, is nothing but the general formula of a simple harmonic progressive wave. Y is equals to a sine 2 pi nt minus x by lambda. So first of all, we'll be substituting the given values in this particular equation. Let us go ahead, students. Also students, one more formula that will help us is going to be v is equals to n lambda. Why v is equals to m lambda? Because over here we have lambda and we have not been given the value of lambda directly. So we certainly have to do v is equals to n lambda to find the value of lambda, and this, students, is going to be our first step. Let us go ahead, students. Further, we have v is equals to n lambda. So lambda very clearly becomes v upon n, that is 200 upon 500, and thereby the value of lambda is nothing but 0.4 meters. Let us start substituting. We have y is equals to a sine 2 pi nt minus x by lambda. Now students, very clearly, the value of a, amplitude, is nothing but 0.01, sine 2 pi as it is. Value of n is 500 and t is 0.01 seconds. Similarly, students, the value of x is 0.7 and the value of lambda is 0.4. Now let us calculate. The next step tells us y is equals to 0.01 sine 2 pi phi. How come phi? 500 into 0.01 is nothing but phi, and over here we have 7 upon 4. Multiply and divide by 10. Same thing. In the numerator we have 0.7, in the denominator we have 0.4. Very clearly it becomes 7 upon 4. Let us calculate further, students. Y becomes equal to 0.01 sine 2 pi into 13 upon 4. 5 minus 7 by 4 gives me 13 by 4. And now simply I will cancel 2 and 4. What is the next step that I get, students? I get 0.01 sine 13 pi by 2. Now students, 13 pi by 2 can also be written as 6 pi plus pi by 2. If you convert this into a fraction, 6 pi into 2 is going to be 12 pi, plus pi in the numerator becomes 13 pi and the denominator becomes 2. Now let us go ahead, students. Sine 6 pi plus pi by 2 can also be written as sine of 2 pi into 3 plus pi by 2. That is sine 2 pi n plus theta. That is nothing but equal to sine theta. That means 2 pi n I can completely forget and only consider the angle, which is pi by 2. So here I can write this equation as 0.01 into sine pi by 2. But what is sine pi by 2? That is nothing but sine 90, which is 1. So the final answer for y is nothing but 0.01 into 1. So y becomes equal to 0.01 meters. Thank you, students, and I'll see you for the next module.
भाई महीने में जैकेट मिल जाएगी।